Okay, now here we have king of questions. Question is in the form of paragraph, and based on this paragraph we have two questions. Question is, let psi1, psi2, f and g are functions from this interval to set R such that f of 0 is equal to g of 0 is equal to 0. Function psi1x is e power minus x plus x. Function psi2x is x square minus 2x minus 2 into e power minus x plus 2. Functions fx and gx are in the form of integrals. Okay, function fx is integration of modulus of t minus t square into e power minus t square. Lower limit is minus x, upper limit is x. Function gx is integration of root t into e power minus t, where lower limit is 0 and upper limit is x square. In both the functions, x is greater than 0. Now we have two questions, and this is a nice way to form the question. We have two options for psi1 and psi2 in one question, and two options in the other question. And for functions fx and gx, we have two options in one question and two options in the other question. Let's first examine functions psi1 and psi2. We have two options in question 1. For all x greater than 1, there exists alpha belongs to open interval 1 to x such that psi1 x is equal to 1 plus alpha x. And for all x greater than 0, there exists beta belongs to interval 0 to x such that psi2 x is 2x into psi1 of beta minus 1. Okay, and two options here. Psi1 x is less than or equal to 1 for all x greater than 0, and psi2 x is less than or equal to 0 for all x greater than 0. So let's first examine functions psi1 and psi2. We have psi1 x is equal to e power minus x plus x. To examine or study this function, we study its derivative. Let's check the trend. We have derivative of psi1 x is equal to 1 minus e power minus x. Okay, and clearly this belongs to open interval 0 to 1 for all x greater than 0. Okay, for x greater than 0, we have 0 less than x less than infinity. We have minus infinity less than minus x less than 0. Okay, then we have e power minus infinity less than e power minus x less than e power 0, means 0 less than e power minus x less than 1. Okay, then we multiply each side by minus 1, we get minus 1 less than minus e power minus x less than 0. We add 1, we get 0 less than 1 minus e power minus x less than 1. Okay, so expression 1 minus e power minus x belongs to open interval 0 to 1 for all x greater than 0. Now with this finding, we can reply for this option 1b and this option 2a. Here psi1 x is less than or equal to 1 for all x greater than 0. Derivative of psi1 x is positive for all x greater than 0. That means a function psi1 x is an increasing function for x greater than 0. Okay, so for x greater than 0, we have psi1 x greater than psi1 0. Okay, psi1 0 is 1. Okay, so we have psi1 x greater than 1 for all x greater than 0. So this option is false. Here psi1 x is less than or equal to 1, but we are getting psi1 x more than 1. So this option is false. Okay. Okay, then we have this option for all x greater than 1, there exists alpha belongs to open interval 1 to x such that psi1 x is equal to 1 plus alpha x. If this holds, then graphs of y is equal to psi1 x and y is equal to 1 plus alpha x will intersect at least once for x greater than 1. Okay, so what do? We draw the graphs of these two functions. Here we have coordinate axis. Okay, psi1 0 is 1, so we mark here point 0 comma 1. Okay, then psi1 x is an increasing function for x greater than 0. So we have this rough sketch for function y is equal to psi1 x. Then we have this variable straight line for alpha greater than 1. This line always passes through point 0 comma 1. Okay, take any value of alpha, line always passes through point 0 comma 1, but slope of line is more than 1. Okay, so we have here different lines having slope more than 1. Okay, and definitely this lines will lie above this graph, because at any point on the graph slope of tangent will be less than 1. Okay, and these lines have slope more than 1, so definitely these lines will lie above this graph. That means these lines won't intersect this graph for any value of alpha. Okay, that means this equation has no root. That means this option is also false. Okay, now we have two options for psi 2, this and this. Here psi 2x is less than or equal to 0 for all x greater than 0. So we study function psi 2x, we find its derivative. Derivative of psi 2x is 2x minus 2 plus 2 into e power minus x. Okay, and this is 2 multiplied by x plus e power minus x minus 1. Now this is very nice question. The reason is all the functions are connected. Like here this is psi 1 x minus 1, and just now we proved that psi 1 x is greater than 1 for all x greater than 0. Okay, that means this is greater than 0. Derivative of psi 2x is positive, so psi 2x function is also an increasing function. For x greater than 0, we have psi 2x greater than psi 2 0. Okay, because function psi 2x is an increasing function. So from this we get, what is psi 2 0? Put here x is equal to 0, we get 0 minus 2 plus 2 0. Okay, that means psi 2x is greater than 0 for all x greater than 0, but here we have psi 2x less than or equal to 0, so this option is also false. Okay, okay, now we have this option. For every x greater than 0, there exists beta belongs to 0 to x such that psi 2x is 2x into inside bracket psi 1 beta minus 1. Now from this, derivative of psi 2 at x is equal to beta will be 2 into inside bracket psi 1 beta minus 1. We have here this derivative. Okay, that means we have to check psi 2x is equal to x into derivative of psi 2x at x is equal to beta. Okay, now we can use LMVT, Lagrange's mean value theorem. Okay, using LMVT we can say there exists beta belongs to open interval 0 to x such that psi 2x minus psi 2 0 over x minus 0 is equal to derivative of psi 2x at beta. Okay, and psi 2 0 is 0, this is 0, so from this we can say psi 2x is equal to x into this. Okay, that means this statement is true using LMVT, Lagrange's mean value theorem. Okay, so this option is correct. Now when you find this option correct, there is no need to check these two options because this question was asked in single correct answer type. Okay, but even then we will check all the options. Okay, now we have options for functions fx and gx. We have two options here and two options here in second question. Let's first check this option. Function fx increases in the interval, closed interval 0 to 3 upon 2. For that we need to find derivative of function fx. Look at function fx. Clearly this function is an even function. Okay, so using the properties of definite integrals, we have fx is equal to 2 multiplied by integration of t minus t square into e power minus t square with lower limit 0 and upper limit x. Okay, here x is greater than 0, so there is no need to put modulus when you have these limits 0 to x. Okay, and function gx is this. Let's first analyze function fx. We find derivative of fx. Derivative is 2 into x minus x square, we are using Lebanese rule, okay, into e power minus x square. This is 2 into x into 1 minus x into e power minus x square. We use sign scheme method to check the sign of derivative. We have critical points 0 and 1. Signs will be minus, plus, minus, because here coefficient of x square is negative. Here coefficient of this x is negative, okay. So function increases here in the interval 0 to 1, okay, but here interval is 0 to 3 upon 2. So definitely this option is false, okay. जो simple option है हम उसको पहले check करेंगे, okay. So this option is rejected. Then we check this option. Here we have f of root log 3 plus g of root log 3 is equal to 1 upon 3. That means we have to find the value of fx plus gx at x is equal to root log 3, okay. Now to get this function, to add fx and gx, we need to have same limits. Here limits are 0 and x, here limits are 0 and x square, okay. We can get limits 0 and x by replacing t with t square. In this replace t with t square, we find gx is equal to 2 multiplied by integration of t square into e power minus t square, having lower limit 0 and upper limit x. Replace t with t square, we find gx is equal to this, okay. Now we add fx and gx, we get fx plus gx is equal to 2t into e power minus t square, integration of this function, okay, having lower limit 0 and upper limit x, okay. Next we can integrate this. Derivative of minus t square is minus 2t, so integration will be minus e power minus t square, okay, having limits 0 and x, and from this we find this is equal to 1 minus e power minus x square, okay. And then we put here x is equal to root log 3, we find this is equal to, putting x is equal to root log 3, we find 1 minus e power minus log 3. This will be 1 minus 1 upon 3 using properties of logarithm. So this will be 2 upon 3. So this option is false, okay. Now let's check these two options, okay. Now for this option we consider function fx. We have fx is equal to integration of 2t into e power minus t square minus integration of 2t square into e power minus t square. Lower limit is 0 and upper limit is x. This is we just got the value of this. This is 1 minus e power minus x square. We are getting this expression here, okay. And here to integrate this we use expansion formula. Definitely this is non-integrable because here we have t square, okay. So we use expansion of e power minus t square. We get 1 minus t square upon 1 factorial plus t power 4 upon 2 factorial minus t power 6 upon 3 factorial, okay, plus t power 8 over 4 factorial and so on, okay. Now we integrate this with this limits, we find fx is equal to 1 minus e power minus x square minus 2x cube over x plus 2x power 5 over 5, okay. Then we will have minus x power 7 over 7 plus 1 upon 3 into x power 9 over 9 and so on, okay. And definitely this will be less than 1 minus e power minus x square minus 2x cube over 3 plus 2x power 5 over 5, because expression from this term onwards will be greater than 0 for x belongs to 0 to 1 upon 2. आप check कर सकते हैं. This expression will be positive. Okay, so we are getting fx less than this, but here fx is greater than or equal to this. Okay, so definitely this option is false. Okay, then definitely this option will be true. Let's check this option. And for this inequality, we evaluate this integral. We have gx is equal to, replace t with t square, we find integrand 2t square e power minus t square with lower limit 0 and upper limit x. Okay, now we use expansion formula of e power minus t square. This is 1 minus t square over 1 factorial plus t power 4 over 2 factorial minus t power 6 over 3 factorial plus t power 8 over 4 factorial and so on. Okay, now we integrate, we find gx is equal to 2x cube over 3 minus 2x power 5 over 5. Okay, then we will have plus t power x power 7 over 7. Okay, and then some expression in x. Okay, and we find that for x belongs to 0 to 1 upon 2, this expression will be less than 2x cube over 3. In fact, less than or equal to, we can put equal to sign also, minus 2x power 5 over 5 plus x power 7 over 7. Okay, so we have gx less than or equal to this for all x belongs to open interval 0 to 1 upon 2. Okay, so this option is true. So in this question, option C is correct, and in this question, option D is correct. Let us look at this question of definite integrals. Question is function f from this interval, closed interval minus pi by 2 to pi by 2 to set R be a continuous function such that f of 0 is 1 and value of this definite integral is 0. Here we have integration of f of t from lower limit 0 to upper limit pi by 3. If value of this definite integral is 0, then which of the following statements are true? This is multiple correct answer type questions. So we have to check all the options. Okay. First option, option A is equation fx minus 3 cos 3x is equal to 0 has at least one solution in open interval 0 to pi by 3. Now, what do you find in this statement? What are the keywords? This equation has at least one solution in this interval. Okay, that means here we can think of using Rowley's theorem. Okay, in that case, this must be derivative of some function. Okay, which becomes 0 in the interval 0 to pi by 3. Okay, so we create a function whose derivative is this function gx is that function. So gx will be here we have fx, so we create here term with integral. We have we must have integration of f of t from lower limit 0 to upper limit x. Okay, derivative of this will be f of x. Okay, so we are creating this term, and this is derivative of sine 3x. Okay, we add some constant. Okay, now for Rowley's theorem, we check the value of function gx at x is equal to 0 and x is equal to pi by 3. We find g of 0 is equal to, put here x is equal to 0, we find 0 minus 0, sine 0 is 0, this plus c, this is equal to c, and g of pi by 3 is equal to, we replace x with pi by 3, and value of this definite integral is 0, this is given, so we have 0 minus, we will have here sine pi is 0, so we have this plus constant c is equal to c. So we are getting g of 0 is equal to g of pi by 3. Okay. So here Rowley's theorem is applicable, and from its argument we can say there exists at least one alpha belongs to 0 to pi by 3 for which g dash alpha will be equal to 0. Okay, and derivative of this is fx minus 3 cos 3x is equal to 0. So this equation has at least one root in the interval 0 to pi by 3. Okay, so here we are using Rowley's theorem. In the second case, In second option equation, this equation has at least one solution in this interval. In this case also we will be using Rowley's theorem. Now here we rewrite this equation by taking minus 6 upon pi. On LHS we get equation fx minus 3 sine 3x plus 6 over pi is equal to 0. Now this equation has at least one solution in this interval. So what do? We create one function whose derivative will be this. Okay, that function hx will be definite integral, this definite integral. Okay, its derivative will be f of x. Okay, this is derivative of minus 3 sine 3x is derivative of plus cos 3x, and this is derivative of 6x over pi. Add some constant c here. Okay, now h of 0, we check the value of hx at 0 and pi by 3. H of 0 will be 0 plus 1, cos 0 is 1, plus 0 plus c, this is equal to c plus 1. Okay, and h of pi by 3, replace x with pi by 3, we find 0 because value of this definite integral is 0. So we have 0 plus, here we will have cos pi is minus 1. Okay, plus 6 over pi into pi by 3 plus 2. Okay, plus constant c, this is also c plus 1. Okay, so this function satisfies conditions of Rowley's theorem. So from the argument of Rowley's theorem, there exists at least one x belongs to this interval for which derivative of this will be 0 and derivative of this is this function. Okay, so this option is also true. Both the options A and B are true. We used here Rowley's theorem. Okay. Okay, now in these two options we have limit involving definite integrals. Definitely we will be using here Lebanese rule. Okay, this one, limit extends to 0 of x into this definite integral over 1 minus e power x square is equal to minus 1. But x is equal to 0, we find 0 over 0, e power 0 is 1, so we have 0 over 0 indeterminate form. We can use L'Hopital rule. Okay, for that we differentiate numerator and denominator separately. Okay, so this limit changes to, limit extends to 0 of 1 into this definite integral. Okay, plus x multiplied by fx over derivative of this, it is minus 2x into e power x square. Okay, now how can we find this? How can we evaluate this? At x is equal to 0, this value will be 1. Okay, so we can replace this with 1. Now we have this. Okay, what do? We split from this plus sign, we find this definite integral over minus 2x plus f of x over minus 2. Okay, we have limit x tends to 0. Here we write separately limit x tends to 0. Okay, now here we can put x is equal to 0, we can use direct substitution. So this will be f of 0 over minus 2, f of 0 is 1, so we have here minus 1 upon 2. Okay, now this is still indeterminate form, 0 upon 0 form. We can use L'Hopital rule. We differentiate numerator and denominator separately. We find f of x over minus 2 for limit x tends to 0, so value of this will be also minus 1 upon 2. We get minus 1 upon 2, minus 1 upon 2 is equal to minus 1. Okay, so this option is also correct, true. Okay, now let's check this option. Okay, now we have here limit x tends to 0 of sin x into this definite integral over x square is equal to minus 1. Let's evaluate this limit. We have we can write like this, limit x tends to 0 of sin x over x multiplied by this definite integral over x. Okay, limiting value of this is 1, so we have now limit x tends to 0 of this definite integral over x. Okay, now this is indeterminate form. We can use L'Hopital rule, using which we get limit x tends to 0 of fx over 1. This is f of 0, value of f of 0 is 1. Okay, so this option is wrong, false. Okay, so correct options are A, B and C. So here we are using mainly three concepts: L'Hopital rule of limit, Lebanese rule of definite integration, and Rowley's theorem. Okay. Okay, now we have one more question from definite integrals. Question is if I is equal to this definite integral, then find the value of 9i. Here integrand function is greatest integer of root 10x over x plus 1. Lower limit of integration is 0, upper limit is 10. Your square brackets represent greatest integer function. How can you find value of such integrals? Integrals involving greatest integer functions. We have done this in separate video. We have one special concept of integration of functions involving greatest integer function. What do you do first? We first check the nature of function inside brackets. Okay, suppose this is function fx. We have fx is equal to square root of 10x over x plus 1. We can write like this: square root of 10 multiplied by 1 minus 1 over x plus 1. We first check the nature of function. We start with x plus 1. In any interval, this function is an increasing function. So 1 over x plus 1 will be decreasing function. Minus 1 over x plus 1 will be an increasing function. So 1 minus this, and hence 10 into this, and hence square root of this will be an increasing function. Okay, so function fx is an increasing function. Then what do? We find the values of fx at end points of intervals. Here we have values 0 and 10. Value of f of 0 is 0. Okay, and value of f of 10 will be square root of 100 over 11. Okay, 100 upon 11 is 9 point something, so its square root will be 3 point something. Okay, so fx moves from 0 to 3 point something when x moves from 0 to 10. So greatest integer of fx will be discontinuous when fx crosses three integers 1, 2 and 3. There will be three integers in the interval 0 to 3 point something. Okay. Now we find the corresponding values of x. We will get corresponding values 1 upon 9, 2 upon 3 and 9. For fx is equal to 1, value of x will be 1 upon 9. For fx is equal to 2, value of x will be 2 over 3. And for fx is equal to 3, value of x will be 9. Okay. So what do? We split the limits at three values, 3 points: 1 over 9, 2 over 3 and 9. Okay. So I is equal to, first we have limits 0 to 1 upon 9 when x belongs to this interval, fx belongs to open interval 0 to 1. Okay, f of 0 is 0, f of 1 upon 9 is 1. Okay, for fx is equal to 1, we are getting x is equal to 1 upon 9, means f of 1 upon 9 is 1. For these values of x, fx belongs to open interval 0 to 1, so its greatest integer will be 0. Okay, got it. Then we have interval 1 upon 9 to 2 over 3. For these values of x, fx will lie in open interval 1 to 2. Its greatest integer will be 1. Okay. Next we have interval 2 upon 3 to 9. Okay. We have here 2. Okay. Then we have 9 to 10. Here we will have 3. Okay. Now we find this value. We find, you calculate yourself, you will get 182 over 9. Okay, so value of 9i will be 182. Okay. Okay, we have one more question here. Functions f1 and f2 are from this interval to set R, where f1x is this definite integral. Here we have product of t minus j power j from j is equal to 1 to 21. This is multiplication operator. We have sigma operator for addition. We have multiplication operator. Okay, we put j is equal to 1, 2, 3 up to 21 and multiply. Okay, and f2x is 98 into x minus 1 power 50 minus 600 into x minus 1 power 49 plus 2450, where x is greater than 0. In both the cases, x is greater than 0. Okay. And mi and ni denote the number of points of local minima and the number of points of local maxima of function f of I, where I is equal to 1 and 2. In the interval, open interval 0 to infinity, then we have to find the values of these two expressions. Here m1 will be number of points of local minima of f1, and n1 will be number of points of local maxima of f of 1. Okay, so how can we find points of minima and maxima? For that we differentiate function. We first write this product. What is f1x? f1x is integration of function. We have integrand function t minus 1 power 1, then t minus 2 power 2, t minus 3 power 3, up to t minus 21 power 21. Okay, now we differentiate this. Simply replace t with x. We get f1 dash x is equal to x minus 1 power 1, x minus 2 square, x minus 3 cube, and so on up to x minus 20 power 20 into x minus 21 power 21. Okay, for points of maximum minima, we compare this derivative to 0. We find x is equal to critical points will be 1, 2, 3, 4 up to 21. We have 21 critical points, but not all the critical points are local maxima और लोकल मिनिमा. सारे जो क्रिटिकल पॉइंट्स हैं वो लोकल मैक्सिमा लोकल मिनिमा नहीं होंगे. ओनली दोज क्रिटिकल पॉइंट्स विल बी पॉइंट्स ऑफ लोकल मैक्सिमा और लोकल मिनिमा वेर derivative will change its sign. Okay, now we know the sign scheme method. Sign will change at the critical point for which corresponding factor has odd power. Okay, so we will consider only these numbers. 1, we are considering factors having odd powers. Okay, so critical points will be 1, 3, 5, 7, 9, 11, 13, 15, 17, 19 and 21. Okay, now we check sign scheme. Okay, we will have here plus minus plus minus plus minus plus minus plus minus plus minus sign change alternatively. Okay, so here all these critical points are points of local maxima or local minima. Those points will be points of local minima where derivative will change its sign from minus to plus. Okay, so points 1, 5, 9, 13, 17 and 21. This will be points of minima. We have here 6 points of minima, so value of m1 is 6 and value of n1 will be 5. There will be 5 points of maxima. 3, 7, 11, 15, 19 are points of maxima. Okay, now we can find the value of this expression. 2m1 is 12 plus 3n1 is 15 plus m1 is 30, and this sum is 57. Value is 57. Okay, now we check function f2x. Now derivative of f2x will be 98 into 50 into x minus 1 power 49 minus 600 into 49 multiplied by x minus 1 power 48. Okay, now this is 49 into 100. Okay, so we can take 49 into 100 into x minus 1 power 48 common. Inside brackets we will have x minus 1 minus 6, and this is x minus 7. Okay, now for points of local maxima and local minima, we compare this derivative to 0. We find x is equal to, we will have two values of x, 1 and 7. Okay, now we put sign scheme of derivative of f2x. Critical points are 1 and 7. Okay, here we will have sign plus, then minus, then minus. Okay, here x minus 1 has even power. Okay, so while crossing x is equal to 1, sign of derivative won't change. Okay, so there is only one point of minima and no point of maxima. Okay, so value of m2 is 1 and n2 is 0. One point of minima, this is point of minima, and n2 is 0. This is not a point of minima or maxima, though derivative becomes 0 at x is equal to 1, but this is not a point of extremum. The reason is derivative is not changing its sign. Okay, now we use these values here. We find value of this expression as 6. Okay, we have 6 plus 0 plus 0 is equal to 6. Okay, now look at this question. Let gi from this interval to set r for I is equal to 1 and 2, and f from this interval to set r be functions such that g1x is equal to 1, g2x is equal to modulus of 4x minus pi, and fx is equal to sine square x for all x belongs to closed interval pi by 8 to 3 pi by 8. Now we define si as this definite integral. It is integration of fx into gix from lower limit pi by 8 to upper limit 3 pi by 8 for I is equal to 1 and 2. Then we have to find the values of 16 s1 over pi and 48 s2 over pi square. Now what will be s1? s1 क्या होगा? Put I is equal to 1. Here integrand function will be fx into g1x. fx is sine square x, g1x is 1, so integrand function will be sine square x only. Okay, lower limit pi by 8, upper limit 3 pi by 8. Okay, now we can easily find the value of this integral. We can use sine square x is equal to 1 minus cos 2x over 2, but we have a simpler approach to get this value. Sum of these two limits is pi by 2. Okay, so we can use this property. This is a very common property. We can replace x with a plus b minus x. Okay, so here we will replace x with pi by 2 minus x. We get s1 is equal to integrand function will be cos square x. Replacing x with pi by 2 minus x, we get cos square x. Okay, limits will be same. Okay, what is the advantage? Sum of sine square x and cos square x is 1. Okay, so what do we do? We add these two s1s. Okay, we get 2s1 is equal to integration of 1 from lower limit pi by 8 to upper limit 3 pi by 8. Okay, so this will be 3 pi by 8 minus pi by 8 or pi by 4. So value of s1 will be pi by 8. Okay, for this value here we get this is equal to 2. Okay, now we have to get the value of s2. Put I is equal to 2 here, we get s2 is equal to integrand function will be sine square x multiplied by g2x is modulus of 4x minus pi. Okay, lower limit pi by 8, upper limit is 3 pi by 8. Okay, now here also we can use same property. We can replace x with pi by 2 minus x. Okay, with the same limits, we get s2 is equal to lower limit pi by 8, upper limit 3 pi by 8, and integrand function will be cos square x into, we are replacing x with pi by 2 minus x, so here we will have cos square x, and here we will have 4 into pi by 2 minus x minus pi. Okay, this will be 2 pi minus 4x minus pi. It will be modulus of pi minus 4x or modulus of 4x minus pi. Okay, now what is the advantage? When we add this, integrand function becomes modulus of 4x minus pi, because sine square x plus cos square x is equal to 1. Okay, so we have 2s2 is equal to integrand function is modulus of 4x minus pi, lower limit is pi by 8 and upper limit is 3 pi by 8. Okay, now we can find this value. For that we draw the graph of y is equal to modulus of 4x minus pi. Now this becomes 0 at x is equal to pi by 4. Now this is mean of these two values. Okay, mean of these two values is pi by 4. Keeping these values in mind, we draw the graph. Here we have coordinate axis. we mark values pi by 8, 3 pi by 8 and pi by 4. Okay, at pi by 4 this value becomes 0. At pi by 8 value will be pi by 2. Put x is equal to pi by 8, we get a value of y is equal to pi by 2, and at x is equal to 3 pi by 8 also value of y will be pi by 2. Okay, so at this two values of x, height will be same. Height will be pi by 2. Okay, and the graph of function will be like this. Okay, now these two triangles are congruent. These two heights are same, these two widths are also same because this is mean of these two values. Okay, so what do? We find area of this triangle and multiply it with 2. Area of this triangle is 1 upon 2 into pi by 2, this height into this width. This width is pi by 8. So area of this triangle is pi square over 32. So sum of areas of these two triangles will be pi square over 16. Okay, so we will have S2 is equal to pi square over 32. Put the value of S2 here, we get this is equal to 48 over 32 and this will be 1.5. Okay.